In this video, we are going to be looking at equivalent fractions. So first, let's all get on the same page about what equivalent fractions are. So the way that I like to remember it is equivalent has something that looks a lot like equal in its word part, but equivalent fractions are fractions that have the same value. Even if they don't look the same with their numerator and denominator, they can have an equal value. So let's first look here at 2/3 and 2/4. They are not equivalent fractions. You'll see that 2/3 is greater than 2/4 by looking at my model here. So remembering that when you're making the models, you want the wholes to be the same size. And then you want to partition it into the number that tells the fractional unit in the denominator, and then use the numerator to focus on certain parts in the fraction and then compare there. So even though these have the same numerator, 2/3 is larger because it's two larger parts. Thirds are larger than fourths. So that's also using a little bit of our understanding of numerator and denominator. So now let's move on here to equivalent fractions and to show you how you can find equivalent fractions. So here I have 1/2, and I want to find some other fractions that are equivalent to 1/2, even if they don't look anything like 1/2. So what I like to do is, here I have some wholes that I want to try to use to find the equivalent fractions. So I know that I want this much of my fraction to be focused on because that's what it is here. So I'm also going to think about here halves. I want to use some units that work well with halves, which we've been noticing that things that work well with halves are fourths and eighths. So I'm actually going to split this into fourths, and then if I shade in the same amount, I can see that 2/4 is equivalent to 1/2. And I can also use what I know about numerators and denominators. So here, if I used this 1 2 times, I would get my whole. If I used this 2 2 times, I would get my whole of 4. So it's kind of also the relationship between numerator and denominator to see if they're equivalent or not. So let me do another example here. Another fractional unit that works well with halves is eighths. So I'm going to make this into fourths. Oops, not good. And then make this into eighths. There we go. And then I want it to be that same amount, so I'm going to shade in where it's the same amount. And here I can see that 4/8 has that same amount that is shaded in. And also here, halves means two equal parts, so I have one part shaded, one part not shaded. In 2/4, I can look at it also as two equal parts because I have two parts shaded, two parts not shaded. In my eighths, I can also look at it as two equal parts, four parts shaded, four parts not shaded. One thing that a lot of times doesn't seem to work well with halves, but in this instance it does, is sixths work pretty well with halves. So I use my thirds, and then I make sixths, and I can see that if I shade in 3 of them, 3/6 is equal to 1/2. Again, because I have two equal parts. 3 of the 6 are not shaded, 3 of the 6 are shaded, 3 of the 6 are not shaded. Let me just do a few more examples here with things that don't really work so well with some of these denominators but work well with each other. So 2/3, so let me shade in 2/3 here. So there's my 2 of the 3 parts shaded in. And so now I'm going to, I know that 3 and 6 work well together, so I'm going to make this into sixths, and then I'm going to find the part of it that looks equal, and I'm going to make that into 4/6. I could also do it in this way. Find my 2/3, and then I could also split it this way, and that's also sixths. Or I could split it again, and now I actually have 12ths. So I have 8/12. is also equivalent to 2/3. So that is a strategy we use. And then you can also look at it as, is the relationship between the numerator and the denominator similar? So here, 2/3, I could also look at it as, if I'm doubling this to get to 4, I can double the 3 to get to the 6. And that helps me also with equivalent fractions a little bit. But the main strategy that we use is these models to show that we understand that the fractional unit is changing to find the equivalent fraction. So use these strategies when you are working on showing your equivalent fractions for homework.